Hello, everybody. Sorry I couldn't be here today, but I'm going to do a little video on what you need to know for the word problems. I'm going to start with lesson 4 because we didn't do the word problems because it was calculator work. So hopefully you brought your calculators today. And if not, you could use maybe your laptop as a calculator with Desmos or something. But otherwise, open your books to page 19 and we will go through example 4 together. All right, so the first thing we're going to do is example 4, which is related to modeling with exponential functions, and we're going to use this formula right here. You've probably seen this before. It tells you over here to the right what everything stands for. A is your final amount. T is the amount of time it takes. We might have intervals of hours, days, minutes. You just have to pay attention. Rate is your growth rate. Remember, you must express that as a decimal. And then P is your initial amount. So I'm not going to be able to show you how to use your calculator, so you're going to have to be able to use your calculator as we go through these questions. So grab your calculator and practice rounding to 3 decimal places, or of course truncating them. But if it's money, we never round to 3 decimal places. We always do 2 decimal places because that's what we do in US dollars. We do to the 100th cent. So it says you purchase an antique statue for $450. The value of the statue increases 5.5% per year. So hopefully you're saying to yourself that 450 is your initial amount, 5.5% is your rate, and then how much will it be worth after 20 years? Well, because our rate is in years, then we know that this is our time also in years. So we're going to try to find our final amount after 20 years. So our initial amount is $450. We are going to add 100% of the money, which is $450. That's why we have this 1 right here, because it's 100% of the money plus 5.5%. So remember my 5.5%, I'm basically dividing that over 100 to get a decimal. So it becomes 0.055. So we put that in here, and then we raise that to the 20th power. So if you plug all of that into your calculator, you should get $1,312.99. So I need the dollar sign, I need to round to 2 decimal places, that's it. So it says, when will the statue be worth $2,000? So what is this 2,000 representing? Well, when will it be worth $2,000? That means my A of X is 2,000. So that means, in other words, I'm doing 2,000 equals 451.055. So I'm just adding that together and putting that here. And then I'm raising this to the T power because I don't know, because the question is when, right? So that's asking, what does T equal? So usually we use our calculator to figure this out. So what are we going to do? Well, this is when we would say, okay, this right here I'm going to put in as y sub 1. This right here I'm going to put in y sub 2, or maybe it's fx1 or something in your calculator, f2x, I don't know what it is. But you put this in one part of your graph, and this is the second part of the graph, and you're finding where it intersects. So your graph, this is what you would have to show on your paper, right? You have a graph that looks something like this. That's this right-hand side. So it's going to look something like that. And then we're seeing where it intersects 2,000. So this is at 2,000. So we're trying to find where this intersects. This down here is our time in years. This is our total money. So what do we get there? You should get a number of 27.860 years. So that intersection point should be 27.860, 2,000. So check it out on your calculator. Again, don't just take my word for it. Maybe I have errors in this, so you want to check it yourself and make sure it's right. And if you get a different answer, check with other people in the classroom to see, or check the answer key and see if there's an error. So the next problem is exponential decay. If something is decaying, that means it is decreasing in value over time, right? Things that grow are your money in a bank or your house. When you purchase a house, usually the amount that it's worth grows. But things like when you buy your iPhone, as soon as you buy it, it starts to decrease in value when you're using it, or a car, when you buy it, it starts to decrease in value. So that would be exponential decay. Same formula, except instead of a plus sign, we have a minus sign because that's representing the decay. So let's read the problem. Example 5, a jet ski initially costs $4,200, but it depreciates each year by 9.4%. So initial cost, that's my P, 9.4%, that's my rate, which I'm going to change to a decimal. And then when will a jet ski be worth $2,500? So that's my A of t, and the question is when, so I'm asking for time. So in other words, to show work, you're going to say 2,500 equals 4,200 times 1 minus 0.094 to the t power. So you can just plug this right into the calculator, or you can simplify it, up to you. This would be into like f1x, this would be into f2x. You would find the point of intersection. You're going to sketch your graph. So we're going to have a graph. Oops, it's decay. So that's not what your graph is going to look like. Again, you should check it, but you're going to have a graph decaying. You're going to have an intersection of 2,500. We want to find this intersection point. And what is the time? This is your time in years. This is the total amount of money. So I've already done this calculator work, but again, you should check it on your own calculator. And if you get a different answer, then make sure you ask someone around you to see what they got, or try to see what you did as a mistake if it is not correct. But I get 5.255 years. And this is the work you would need to show to support your answer. All right, this is example 6. I am going to skip this one because I think we're just going to move on to lesson 5. Hopefully you have had the hang of it, but you can practice and go through the rest of these. If you were to do this problem, you should get 45.291 years. You could pause your video right now and just try it on your own. If you feel confident about what's going on, then I would just say move on to lesson 5. Okay, moving on to lesson 5. This is our final lesson, our final new bit of information for semester 1, and it's on compound interest and half-life. So compound interest and half-life. Compound interest, or what is interest in general? If you open a savings account in a bank, you make interest, a very small amount, but the reason you make interest is because they're using your money to lend it to other people. If you have to be one of the borrowers of money, then you're going to get charged interest because you're borrowing money from the bank, therefore they're going to charge you some interest to get it back. This particular section is on compound interest. So with compound interest, that means instead of earning interest just once per year, you're earning it more often, and it's accruing with everything else. So the number, N is the number of times you're compounding per year, and everything else is the same. So if we have an annual interest rate of 6%, and we compound it 4 times per year, then you're not going to get 6% 4 times per year. You're going to have to break that 6% down 4 times, and then you're going to divide that by 4, so you're only accruing 6/4 or 1.5% each quarter. But you'll get a little bit more money because you're getting the percentage on the money with the percent. So we'll see as we move on here. Okay, so I'm skipping the example 1. You can go through that on your own, but that's kind of building the idea of compound interest for you. Sorry, I kind of just explained it, ruined the big surprise, just shared the formula with you, and now we're going to do example 2 to see how to use the formula. So it says, how much would you deposit in an account that pays 6.25%, compounded semi-annually, so that's twice per year, so my N is 2, sorry, that's an R, to have a balance of $5,000 in 15 years. So we can see that 6.25% is our interest rate. Semi-annually is the number of times you're going to compound it per year. The balance is what you want to end up with, so that's our final amount. So we want to end up with 5,000. We don't know what our initial amount, that's what it asks for. How much would you initially put in there? How much would you deposit? Our money is growing. We change our interest rate to a decimal. We divide it by the number of times we're compounding by per year. And then, of course, if we have 15 years that we're compounding it, but we're doing it twice per year, you need to make sure that you are raising that to the power of 30, right? So it's twice per year for 15 years, so that's 30 times altogether. Now, this is just one giant number. Again, I can't show you the math right here. I don't have my calculator. I mean to show you what buttons I would push, but I'm just going to calculate 1 plus 0.0625 divided by 2 to the 30th power, and you should get somewhere around 2.517. Then we divide that by both sides. So again, plug that into your calculator. Make sure you're getting that. Don't just take my word for it. Maybe I'm wrong. So your initial amount that you would have to deposit in order to get $5,000 after 15 years is $1,986.33. Kind of shocking, isn't it? It's going to take 15 years for this 1,900, almost 2,000 to go to 5,000. Or maybe it's just free money. You just let it sit there. No big deal. All right, moving on to example 3. If I were you, I would just pause for a second and try this on your own. I would pause it, try all of this work on your calculator on your own, and then unpause and check your work here with me. Okay, if you tried it on your own, you should have gotten $3,960.44 for part A. Why? Because we take our initial amount of $2,850. We have a 4.12% interest rate compounded monthly, which is doing it 12 times per year. So we have to take that interest rate and divide it into 12 because it's happening 12 times per year. And then, of course, if we're investing it for 8 years, we have to multiply 12 times per year for 8 years. So it's to the power of 12 times 8. When I plug all this into my calculator, I should have gotten $30,960.44. On the second one, it's asking us to double our value. So doubling your value, you could have just done this right here, right? You could have just put a 2 here and a 1 here. No matter what your value is, if you double it, when you divide that, you're just going to get a 2 here and a 1 here. And then graphing this makes your window so much easier because you're not going up to $5,700 or $6,000. You're just going up to 2 on your y-axis. So it's so much easier if you just start here. So have a look. If you're not sure, ask people around you to clarify why that might be easier. It's not necessary. You could have gone here. It just means your window is going to be a lot different. So again, we're finding intersection between 2 and this right-hand side. So I put this in. That's my blue line. I put this in, which is 2. I see where it intersects. You should have gotten 16.853 years. Now let's look at part C, perhaps a little more complex. It says, if you were compounding quarterly, what interest rate, so here's my question, what interest rate would we need in order to produce the same value if we were compounding monthly for 10 years? So first of all, I need to find how much money we would have in 10 years if we were compounding monthly. So remember, I had the $2,850. I have the interest rate of 4.12%. I'm compounding that monthly, and it says I'm going to compound that monthly for 10 years. So I should plug this into my calculator to see what my total is. And if you do that, looks like you should get $4,299.99. So that is how much we would get if we compounded monthly for 10 years. Now, the question is, what interest rate would we need to receive if we were to compound quarterly? So for 10 years. So we are going to have $4,299.99, and we are still going to start with $2,850. And We don't know the interest rate. That's what it asked us about, but we know we're going to compound quarterly. And if we compound quarterly, that's 4 times per year. So my n value is 4. And then of course here I'm going to have 4 times 10 because n is equal to 4. So I had to find my total, then I had to plug that in here. I still have the same initial amount, I still have the same amount of time, but this time I'm compounding quarterly and I'm trying to find my interest rate. So the only way you're going to be able to do this is to make this y sub 1 in your calculator, y sub 2, find the point of intersection. So I would like for you to pause and do that on your own, and then check your answer with me after you pause. Okay, if you're stuck, you're probably not making an accurate window. Remember, you are trying to find the interest rate. The interest rate is going to be between 0 and 1. It's going to be teeny tiny. The interest rate is going to be small. This is only an interest rate of 4.12, which is really 0.0412. So when you're looking at your graph, that would, if you went from 0 to 1, 0.04 would be way up here somewhere, that intersection. So keep that in mind when you're trying to find the intersection. You're going to have to you're going to have to change your x-axis to be a really small number from 0 to 1. So your interest rate is from 0% to 100%, and it's probably going to be between 0 and 0.1, actually between 0 and 10%. So keep that in mind. Try again. Change your window. And what should you get for an answer? You should have gotten an interest rate of 4.134%. So we compound it less times, which tells you you're going to need a slightly higher interest rate because you're compounding it less times. Talk to someone around you if you're not sure what's going on. Okay, the final example I'm going to do with you is using the half-life formula. You should go through examples 1 through 4 to kind of see what's happening, the buildup of that carbon-14. Why is the half-life time 5,730 years? So you might want to pause and try to go through those on your own and look at the answer key. But now I'm going to specifically do a problem that's using the half-life formula, which is here. So half-life is usually some kind of scientific related activity, so radioactive substance, exponential decay. So what does it mean? It means something is literally halving itself over a period of time. So we have our final amount, right? Our A is our final amount, our P is our initial amount, and then we have our raising it to the half, our base is half because it's halving itself, but then we have 2 different times. We have the actual time that the substance is decaying for, so that's the overall period of time, and then you have the H, which is the half-life time, how long it takes for that actual substance to half itself. These formulas will be given to you on the assessment, but we won't tell you what the letters stand for. So the formulas will be given, but we won't tell you what the letters stand for. So read through this question. It says if a sample of carbon-14 had changed from 15 grams to 6.054 grams, how long had it been decaying? So what is that asking? So just have a pause for a moment. Identify for yourself, what is 15 representing, what is 6.054 representing, and what is the question asking for? Which variable is the question asking for? So hopefully, after some thought, you've decided that 15 is your initial amount, right? That's your P. You're starting with 15 because that value is going to decrease over time because it's halving itself. So this is your final amount that you're going to end up with. And then how long had it been decaying? Is that the T value or the H value? Well, it's the T value. It wants to know how long will that substance decay, and in the previous example, you could look at the one just above, example 4. You see the half-life time. The half-life time for carbon 14 is 5,730 years, so that is your H. So now all I'm going to do is plug it in, use my calculator to solve, and I'm done. So I have 6.054 is my final amount. I started with 15. It's halving itself. I'm trying to find the T, and I know that the H is 5,730. So really your only choice is to put in y sub 1, y sub 2, and find the point of intersection. So try that now. Put in y sub 1, y sub 2. Now this is telling you what your y-axis should go up to, so I would probably go from 0 to 10, knowing that your 6.054 is going to be here, and you're going to see where that intersects this model right here. So what is that going to look like? It's decay. So go ahead and plug it into your calculator, pause, and then come back when you get your answer and check it. Now again, a hint, the hardest part with this calculator portion is deciding on your window, right? This number right here indicates your y value window, how high up it should go, so it has to go beyond 6. And then what helps us determine what our x-axis should be? Well, we're trying to find time, and look, this number that we're dividing by is 5,730. So we need to have an x value that goes beyond 5,730. So I'd be going probably to like 10,000 just to give myself plenty of space. So you need to adjust your window. This number right here helps you. That t has to be bigger than that because we know it's halved itself. Half of 15 is 7.5. So we know it's going to take at least 5,730 years, and it's going to be a little bit more than that because it did more than halve itself, right? So go ahead and plug it in. You find that intersection, adjust your window if you need to, pause and adjust your window. And you really need to try these on your own. Don't rely on just looking at the answers and the answer key. So when you paused and adjusted your window, you should have gotten this intersection point, and you should have gotten an answer of 7,581 years. So that should have been the approximate answer for when the carbon 14 sample will go from 15 grams to 6.054 grams. So use this time today, practice all of these word problems, practice using your calculator. If you forgot your calculator, that's unfortunate. You really need to practice with it because remember, this is the first thing you're going to do when you get that test. So good luck. Make sure you practice. Have a great long weekend, and I will see you on Tuesday after this long weekend to review because your test is on Thursday the 30th. Bye.